Okay, here's the setup for the pinball STM32 control system. This is the STM32 microprocessor. It is driving a 4-channel relay board, and that 4-channel relay board is driving the score wheels from a Bally pinball machine. Now only the solenoids and the 0 switches are hooked up on this set of wheels. Nothing else is hooked up. And power for the wheels is provided by the another Bally pinball machine power supply. And if you look at the blue and green wires, that's picking up the 50 volts AC off of that power supply to power these AC solenoids here on the code wheels. So I'll go ahead and plug this in. The code that's running is simply randomly setting each of the wheels, waiting a couple of seconds, then running them back to 0, and then repeating. Excuse my video for a second while I plug this in. So the wheels just set to 0. Now they're randomly setting each wheel, waiting a couple seconds, and setting back to 0. And 0 is facing straight forward, so right there it's set to 0. And that's it so far. Okay, now that you've seen the hardware in operation, I'm going to take you through a little bit of the schematic drawing just so you have maybe a slightly better understanding of what we're doing or how this test configuration was set up. And I'll even take you through a little bit of the code for the STM32 microprocessor that we're using. Now I'm not going to go into any depth trying to teach you how to program in the Arduino IDE or what the differences is about these different microprocessors and stuff. I'm assuming that you have some background in that already if you're thinking about building a project like this, and if you're just here because you're interested in what we've done, there are literally hundreds of thousands of videos on Arduino programming, and the STM32, also called the Blue Pill. You can look at those and find out about them. Just look on the web and you will find something, some information about that capability, those processors and what they can do. The main reason we are using an STM32 instead of an Arduino is it is a lot faster, it has more program memory, and it has a lot more interrupt inputs that we can use to rapidly process keystrokes or key switches when balls go over rollovers and things like that. Right now on this machine, what we're trying to do is just determine whether or not we can use these relatively inexpensive relays to drive our mechanical devices like the solenoids and the score wheels, and also other things like the bells and the drop target resets and things like that on the pinball machine. So the first thing I want to do is take you into the schematic that we're working with. I'll make this as big as possible just so that it's easier to understand. So here's a little drawing of kind of what a score wheel looks like. There is a solenoid that pulls in when it's energized, and then when it releases, the wheel advances to the next position. There is a zero switch that is normally closed in every position except the zero position when it opens. So as this wheel rolls around and circles around as you're incrementing up, when you get back around to zero, this will open to indicate to whatever logic is controlling this that you've come back to zero. Now, the solenoid is a 50-volt solenoid, so we have a transformer that's providing 50 volts to drive that solenoid, and we have our 4-channel relay control board that is switching that 50 volts on and off. It's a quite simple circuit. The relay control comes from the STM32 microprocessor, and it basically has a set of 4 inputs. The one wheel goes to PA3, the other wheels go to PA4, PA5, and PA6. And this PA is just an assignment of the port names. So this is port A, pin 3, port A, pin 4, port A, pin 5, and port A, pin 6. To drive the relays, we're using port B3, B4, B5, and B6. So A3 reads the zero switch, and B3 activates the relay. And that's it. It's a very, very simple circuit. In a set of loops, and I will show these to you in a minute in the code, the STM32 will pulse the relay on, which will pull the relay in. About 20 milliseconds later, it will release that relay and the wheel will step. When that relay steps all the way back to zero, the zero switch will open, and this pin will see that that is opening and know that the switch has gone back to zero, and if it's doing a reset operation, it will stop resetting at that point. So that's the entire logic of this test circuit. It's repeated 4 times. Like I said, this is just one of the 4 loops. So now let me step over to the Arduino code for you. The STM32 can be programmed in a multitude of different ways, but some guys have spent a lot of work developing an Arduino IDE interface for the STM32. Search on the web for STMduino, and you'll find all kinds of information about it, how to get it set up. There's some great videos out there showing you how to do it if you ever want to do it yourself. Now, in this code, the first thing I do up at the top is I establish 4 counters. I mentioned earlier in the video that I am doing this as a test to see how long the relays will work, or if they will work for an extended period of time. And in order to have some understanding of how well they're working, I have to know how many times I've pulsed these relays. Just FYI, I'm up to about 25,000 pulses on each of the 4 relays right now, and I haven't had any problem at all. So initially it looks like it's running pretty good. I plan to at a minimum test it for 100,000 pulses, and right now at the rate it's running I can do about 5,000 pulses per hour. So I've got a few hours of testing ahead of me. So anyway, as I said, I established some counters, then I established my pin modes. So PB 3, 4, 5, and 6 are outputs. Those are the pins that drive the relays and turn them on. And then PA 3, 4, 5, and 6 are the inputs from the score wheel. And you can see here that they're pulled up, they're inputs with a pull-up applied. So that means that if the switch is opened, that pin will go to 5 volts because of that pull-up. If the switch is closed, which it is for 9 out of the 10 positions, that will be a 0 because the pull-up will be shorted out. Then I establish my my serial interface because I do write out the counts of this as it's going along. I then set all of the outputs high. The high state for the relay is the off position. You drive them low to turn them on and make them pulse. So I send it all high just to make sure that in this setup routine, they will all the relays will be turned off and the solenoids won't be pulled in. I then run a routine called reset to 0. Since I don't know the state of the solenoids right now as the test is beginning, I want to make sure that they all go back to 0. So down at the bottom of my code, I have a routine that's called reset to 0. And it simply resets all the counters at one, or all the wheels at one time, to 0. And the way it does that, it runs a loop 10 times. It writes out to the relay port a 0, and driving it low turns it on. But before, I'm sorry, let me start that over again. It checks to see if, I don't want to edit this, sorry about that. It checks to see if the 0 switch is a 0. If the 0 switch is a 0, that means it's not on 0 because it goes high, goes to a 1 when it's on 0. So if it's not a 0 now, it pulses the relay low, which pulls the relay in. And it increments the counter for that relay to say, I've pulsed that relay 1 time. Then it goes to the next relay and checks to see if it's at 0 yet. And if it's not, then it pulses it 1 time, does the same thing for the other 2 wheels, there and there. And each time it's incrementing the counter for that specific wheel to let it know that it's been pulsed. Then it delays for 20 milliseconds. And then it writes each of those back high, which will turn off the relays, release the solenoids, cause all the wheels to advance, and it'll delay 120 milliseconds, and it'll repeat this loop again. And it'll keep on repeating this loop. And one by one, these things are going to get to 0, and once they get to 0, it'll no longer do the resets, so they'll stay at 0, and after 10 times through the loop, the routine will return back up to here where it started from. I then reset the counts to 0. While the counts were being incremented, but I don't want to use those counts because they're an odd number, and I want this thing to start off with all the wheels at 0 and all the counts at 0, and then I'll start my long-term test. So the long-term test is kind of almost identical to the resetting, except I only do it 1 wheel at a time, and I use a random number generator. So I set a temp value to a random number between 1 and 9. I know this says 1 and 10, but the last number here is exclusive, so it won't do the last number. It'll do a number below that. So this says generate a random number between 1 and 9, and then the next loop says loop through this loop here that many times. So let's say it generated a 5. It will loop through this 5 times. It'll drive a low out to turn to pull the solenoid in. It will delay 20 seconds, and then it'll send a high out to release the solenoid. It'll increment the count. It'll delay 120 milliseconds, and it'll repeat that until it's done it 5 times. And then it'll drop to the next line where it resets the random number to some new random number. And notice that I'm not checking for 0 here. Since I should be pulsing less than 10 times, I shouldn't be able to get to the 0 here, so I didn't bother checking for it. But anyway, I generate a new random number, and for PB4, I send out that random number. And then I do a new random number for the next wheel, and a new random number for the last wheel. I delay a half a second, 500 milliseconds, and then I run that reset routine, which brings it back to 0. This time the counts for the reset are added into the counts that were counted for these random numbers, and the combination of the reset counts and these counts should make every wheel reset back to 0 with a count of 10. If I get a larger count, like 11 or 12, it means that the relay pulled in, but it didn't pull in far enough to actually activate the wheel, and so it didn't advance, and so I had to pull it again. And if I start seeing something like that, I'll know that my relays are starting to fail and not providing enough current out to the solenoids to pull them in. And that's kind of what I'm looking for. So now let me go ahead and let me point out one other thing. After I get done doing that, I print out all the counts each time through the loop before I delay that half a second and start another half a second and then go back and restart again. So this is shows me the count incrementing up as it's running. So what I'm going to do is open up my serial port, and I'm going to plug in my unit again so it'll start counting, and you'll hear it start clacking. And of course, for some reason, it's not outputting anything. Let me try that again. So you can see every time through the loop, it's incrementing each of the relays by 10. And if I got some odd number, then it wouldn't work right. I can simulate a failure like that by pulling the reset wire out of one of these. So I'll pull one of the reset wires out, and now you'll see that one of the numbers is going to, relay 4 there has now got a bad count on it. It gets messed up, and I see things like that, I will know that my relay is actually failing. So let me stop this. And that's it. That's pretty much all that this test is trying to accomplish for now. As we get farther on in our setups and stuff, we'll find other things to video and show you guys how we are progressing with this conversion. Thanks a lot. Bye-bye.